All right, let's start again at question 21. They tell us that we have two apartment tenants have a total of 1,800 feet of fencing to enclose a rectangular garden and subdivide it into two smaller gardens. And you can see they have that diagram shown for us. They want us to express the area as a function of x. Well, the entire area would be x times y. And I need to figure out what I'm going to substitute in for y. So I know that 3x plus 2y, the amount of fencing that they're using, will equal 1,800. And I'm going to solve this this equation for y. This will be 1,800 minus 3x all over 2. So our area will be this quantity here times x. So I'm just going to browse through my options here and choose option A as the one that matches our work. 21, we have another area problem. We have a rectangular garden with a known area of 256, and that equals x times y. This one gets a little bit more complicated because we need to figure out the cost and the cost of the inner wall here, x, and the outer wall, which is y plus y plus x, has a different cost. So before I worry about the cost, I'm going to figure out a better representation for y. Y will equal 256 divided by x. So my cost is going to equal 10 times x, which we can see on the diagram in green, plus 29 times all of the 4 walls shown. So that's going to be 2x plus 2 times y, which we know is 256 over x. And if we distribute that 2 in, we would get 512. So option C is 10x plus 29 times that quantity. That is our best solution. More area. Number 23, a kennel owner has 400 feet of fencing, so the area equals xy. 2x plus 2y equals 400, or x plus y equals 200. So they want us to express the area, x times y, as a function of x. So again, I'm going to solve for y, and that x plus y equals 200. That means that y equals 200 minus x. That quantity must be multiplied times x, and we can see that that's option B. 24, we have a person investing money. Part of their $17,000 was placed in a stock that earned 15% interest, and the rest lost 5%. So the way we would want to set this up is we want to figure out the total income from both investments as a function of x. Well, the first one, I earned 15%, so I invested x and earned 0.15, and I can see that some of these options will not work. That 15% should not be negative, so option D can go away. This x should be multiplied by times 0.15, so option A can go away. Now we need to figure out what to do with the income that we lost, and I think we just need to investigate the answers here. What's different between them is just the sign in the middle. Well, if I lost money, I should be subtracting, so I don't even have to really go much further to know that option C here is the best. Here we have on number 25, we're looking for the domain of a rational function. I know that the denominator must not equal 0, so my domain is such that x must not equal plus or minus 9. So we can see here our solutions are given in set builder notation, and I'm just looking through them. And it looks to me that options C and D are identical, which might be a mistake, but that's all right. I think we may want to list them least to greatest. That might be the difference here. why we would choose C over D. Number 26 is a direct proportion problem. So they tell us that the resistance is directly proportional to the voltage. So we could set up a basic equation of R equals V times, sorry, not V, K times X, where R will be our resistance and X will be our voltage. We need to figure out our constant. That's our first step here. So they tell us when 7 volts are applied, 100 milliamperes of current flow through the circuit. So that means we can set this up as 140 equals K times 7. K is our constant. We can see here is 20. So our real formula here is R equals 20x, where R is our resistance and X is our voltage. All we need to do to find the new current is plug in 9 for X. And we can see that 20 times 9 will be 180 milliamperes. Number 27, they are asking us to find the y-intercept of a polynomial. That always entails plugging in 0 for x. So I'm going to plug this in, and we're going to be left with a product that I'm going to evaluate. Well, here we have to deal with our exponents first. So it's going to be 1 times -5 times 1. All of that multiplied together gets us to -5. Number 28 here, they tell us that the perimeter of a rectangle is 42 feet. They want us to describe the possible length of a side if the area is to be greater than 90 square feet. So let's write down what we know. We know that 42 will equal 2L plus 2W. So 21 would equal L plus W. And we want our area, L times W, to be greater than 90. I'm saying greater than, but not equal to, just based on the problem given. So I'm going to recreate this quadratic as an inequality. I'm going to plug in L equals 21 minus W. So 21 minus W times W must be greater than 90. I'm going to expand this out. I'll get negative W squared plus 21W minus 90 is greater than 0. And I don't like that negative leading out in front, so I'm going to divide this whole inequality by a -1. I'll have W squared minus 21W plus 90, and because I multiplied by a -1, I'm going to flip my inequality. So when I factor this, I will get W minus 6, and W minus 15 is less than 0. So I have these critical values, right, on my number line, basically at 6 and 15. I'm trying to figure out when this inequality here is beneath the y-axis. Well, we would be positive here, negative here, and positive here, which means our solution set would fall between 6 and 15. So that's our option we're going to choose here. Option A, the length of the rectangle must be between 6 and 15 feet. Number 29 is a log problem meant to confuse you. Here we have 10 raised to the log of 4.5. Well, we know that this log base 10 is implied even if it's not given. So this this expression really looks like 7 times, well, 10 raised to log base 10, those are inverses, and we're just left with the number in question, the argument. So we're really looking for 7 times 4.5. 7 times 4.5 is 31.5. Finally, on number 30, we have an exponential equation that we're going to go ahead and solve. Now, they even tell us to use our calculator here. So just so it's clear in this equation, this whole quantity, 3x minus 9, is the exponent, e raised to the 3x minus 9. We're subtracting from that 7, and we want to find when that all equals 1169. What I did on my graphing calculator, obviously we can't see it now, but we graphed e raised to the 3x minus 9 -7 minus 1,169. So basically, I set my entire equation equal to 0 and found my x-intercept. I found that x-intercept to be 5.36. And let's pause there.